through coaching, mentoring, and grooming techniques. Balagaru is working member in Open Group and ISO standard bodies and currently serving as chairman for Computer Society of India, Hyderabad chapter and treasurer for IEEE Hyderabad section. We welcome you, sir, for the session. Over to you, sir.
Thank you. Let me share my screen.
Yes, sir.
Let me know once you're able to see my screen.
Yes, sir, it's visible.
Okay. Thank you, and good afternoon, everyone, for getting into this. First of all, a very good conceptualized faculty development program on challenges for adapting using machine learning for the 5G and 6G areas. Even though 6G is pretty much new to the entire journey, not much people are aware of it. We are about to get into the 5G networks soon. So it's important that we understand the use cases, applications of it, how does it get applied. I'm not sure about the level of the audience who are involved here. Hence, what I decided is I will break down my entire talk into 3 pieces. The first piece of the talk, I'm going to touch upon the machine learning basics, which tries to touch upon some of the important and core concepts of machine learning, which you need to be aware of. In case if you are aware of machine learning concepts, it will be like a refresher thing for you for the next 30 minutes. The second capsule of my talk will be more focusing on the 5G related use cases and applications associated to it, where it is relevant, how it is relevant, and where ML can play a role in the entire journey of the 5G revolution. The last segment of my talk will be focusing on the 6G aspects, where I'm going to touch upon how 6G relevance is going to make a big difference, how it will start bringing in that ultra latency, ultra reliability, and ultra efficiency in the entire network and system of operations. And finally, I'm going to also touch upon one of the important white paper, which is published in the 6G flagship conference, which is released by the University of Polu. This is one of the first and foremost university which has started working on the 6G area, and the research was very commendable. And the paper which has been released really opened up a lot of research challenges, which you need to be aware as you are going to be working on some of the machine learning related aspects using the 5G technologies. So let me get started with the applications of machine learning. Now, today when we are trying to look into the overall segments of social media life, where we are trying to get involved in, you see that every piece of the gadget what you try to use today has got some or the other element of the artificial intelligence. You speak about your mobile phone technologies. You speak about the communication with the different people using your smartphones. Involves a piece of AI in it. Today, integrated natural language processing through the Siri in your iPhones, or Alexa, which is popularly from the Amazon, tries to advocate how it is able to process the NLP speech processing techniques, use the speech processing techniques, interpret it, and also intelligently respond to your needs. One of the common use cases you also see is about the Google Maps. You pretty much use day in and day out whenever you're traveling from one location to another location to find out what is the expected predictable time to reach to the destination and what is the optimal path to reach to the destination in case the traffic is involved. That also continuously try to monitor, take the data from the field, analyze it, and try to provide you the recommendation how much time it takes. It is an approximate talk, but approximate estimation of the time of reaching the destination. But it all depends upon the data it tries to accumulate and predict the things where you see. Similarly, if you're trying to look into the factories of the future, or you're trying to look into the remote monitoring of the systems, it uses again the AI systems. Social media popularized this entire machine learning to the next level. Today, if you see, you're able to connect with your friends, all those things, the possible connects to the connects, it's all establishing this kind of a relationships and providing you that kind of a connectivity. And it also enriches your branding in the consumer segment and also enriches, helping you to upsell your products to the next level. Even if you're trying to look into your email systems, the spam filters, again, intelligently poised with the rule-based machine learning techniques. Today, if you're trying to look into the call center management systems also, many call centers are today leveraging the chatbot communication to communicate with their customers. The initial level of questions gets addressed because 60 to 70% of the questions what they get at the level 1 are pretty much the same, and there is a pretty standard answers which are available. Okay, similarly, if you look into the Google, which is one of the most simplest method of talking about the machine learning, leverages ML techniques to intelligently contextualize the needs of the different end users and trying to provide that kind of information. Similarly, any kind of a product you take, I mean, you take Amazon.com or the Flipkart or Myntra, you see that they try to give you the product level recommendations to cross-sell some of the products or upsell some of the product services. It's all possible because they have the data and information available. They quickly analyze the data and meaningfully push the recommendations which can be analyzed further. And this were not possible before AI was there, but it is all possible because of the machine learning concepts were completely tapped in and intelligently leveraged. If you really take a look into the space of where do I apply machine learning, it's important that we start understanding there are 3 important areas where you can really look at. Wherever there is a data which I need to form a cluster of groups, or try to do the classify the particular data sets. You can classify in terms of the gender or in terms of the race, ethnicity, and many more, and formulate the recommendations which can meaningfully understood and leveraged. These are all important areas what you need to be aware, because whatever you're trying to teach to the machine is all about trying to touch upon and help the machine understand how the human interprets and responds. So it's all about the human-machine interaction which is trying to drive, and you are trying to make human-like thinking to be mimicked by the machine. And it requires good amount of techniques to be leveraged for machine to understand, interpret, and respond. Typically, looking into some of the responses like what you get, if you want to really set the responses region-wise, say for an instance, from which region or which segment I'm getting the data. Say for an instance, this particular faculty development program is coming in. This faculty development program has got a lot of feedback which is captured at the end of the day. What do we do with feedback? How do we analyze the feedback? And what category of people who are trying to give the feedback, positive, negative, neutral. So such kind of a cluster view you can get it, which can really help you to meaningfully analyze and make sense out of it. So making that kind of an observations and formulating into such kind of a meaningful groups is one of the important application area where the machine learning can be leveraged. Some of the common questions which can be addressed through the clustering is like whenever you're trying to look at from the retail marketing purposes, you need to understand which segment and which target group I want to really position my promotions. So you see that many textile industries roll out promotional offers. Jewelry industries also roll out promotional offers during a particular month or a particular cycle where they see there is an opportunity for the buyers to take it. It could be auspicious months or it could be auspicious festivals. That's what I try to target that particular segment. So targeting the children for a specific product is important. Targeting the female segment is important for a particular need. Targeting the male segment for a particular need is also important. Let's say, for instance, if there is a sports event is running and you suddenly flash a jewelry ad, it really does not fly. But if a sports ad is running, but if you are giving an energy drink or if it is a sports shoes, it really captures the attention of the people who are trying to see, because that segment of the people are in that thought and it is easy to produce. So today machine learning algorithms are leveraged for the media industry to help them understand when to, for the media industry to let them know when to really recommend what kind of an ads at what point of time. And that's where the higher attention is provided, higher conversion is possibly made at the point of time. So not only the recommendations to be made head on, but it really does not. That recommendations to be played in such a way that it will really drive the conversion, I would say. And similarly, some of the questions, if you may want to answer through the clustering, is which neighborhoods in a country are more similar to each other in terms of agriculture, in terms of the industry growth, in terms of the education, or in terms of sports. So you try to draw in the similarities and try to leverage those things. So this comparative studies really helps when you with the help of the clustering based application. This application is definitely fall into the clustering category. And similarly, when you want to answer like what groups of insurance policy holders have high claim costs, the reason is every industry has got specific questions to answer, because you cannot give for all insurance customers the similar kind of a premium. You need to measure the utility of the individual, health of the individual, uh, and you need to see how they will be able to, whether they are ready to claim the policy or they are going to sustain the policy for a longer time. All these factors play an important role, and if this needs to be analyzed earlier, it will be a human-related things and it could trigger a human error. But with the feeded input into the machine is able to recommend what is the probability this person can claim, what is the probability this person can get into a defaulter list. All such kind of possibilities can be really looked at. And how do you group the products? Now, generally, if you go to any particular store, retail store, you see that there is a stack of products which are combined and kept together. You need to give a thought that why such kind of a decisions are. It is not an ad hoc decision. You need to be aware of the fact. So some products are placed intelligently because they see that there is a synergy between one product with another product. So you could see that biscuits are placed near to the tea or milk powder. So there is an opportunity for you to pick it. So the possibility of the two different products play an important role to buy each other is important. And similarly, if you are trying to look into the media space, like how do you group pictures based on their descriptions? How many entertainment industries leverage this because there is a huge amount of caption which can be triggered based on computer vision based algorithms, where you can really look into the picture and name them. Similarly, if the names are available, if the metadata is available, you can group the pictures based on their description. So you can get all tiger images together. You can get, if you go and search that I need all zebra images, you will be able to get all the like-minded zebra images together. These are all possible images for clustered, and it's easy for you to get those things. The second important area where you see is about the classifications. That is an important area you need to understand. The reason I'm trying to touch upon clustering, classification, recommendation is when we get into the 5G use cases also, this basic foundational concepts plays an important role. And in the classification area, you need to understand that you need to predict the class from the observations. Now, you try to talk about even the customer segments in the telecom network, right? You have a premium customers and the people who get into the level one where they take all the possible services from the telecom provider. You talk about the Airtel, they try to provide you the Airtel Black. So where they say that you take Airtel Black offer, you get the, the entire Extreme box, you get the internet services, you get the 3 to 4 mobile postpaid connections at all in one package. So that is for the premium customers. The second level, there could be a differential rates and differential bandwidth under which you, with differential data plans under which they try to provide. So that's a different class of customers. When you classify the customers based on the different categories, that also gives you a different level of an understanding where these particular customers will be plot in your entire canvas. So that classification is important for you to roll out separate offers to the separate customers so that they can significantly stay with you for longer time. And if you really look into the applications aspects of the classifications, some of the key questions which you try to answer is which category of mobile products is most interesting to this particular customer. Basically, you're trying to understand the pulse. Say for an instance from the telecom provider segment, if you are a frequent traveler overseas, they need to understand that you are a frequent traveler, communicate to you that there is a specific plan available for you since you're a frequent traveler. There is international travel data plan and international travel plan is available. And under if you subscribe to that, you get it at a very subsidized rates. Such kind of a categorization is possible. And if you are even looking at the classification about the spectrum allocations of the telecom provider, that there also you may be finding machine learning playing an important role. So similarly, looking into the category of the movies, if you want to classify the movies a romantic or documentary or thriller, you can use ML to do that based on the storyline what they try to read and understand and anticipate. And you can also review certain things and try to come to a conclusion that whether it is written by a person or a robot. And if you have really wanted to check out the possibility of buying a product or not buying a product, you can get those answers with the classification, because if the purchasing power is high, they not only search for your product but they also buy your products. Looking at your purchasing interest history and the conversion history, they will be able to predict the possibility this person will do this transaction. Looking into your emails which are entering into your system also, if you want to classify under the spam or any kind of a promotional offer, that is also possible. Today you see um, such kind of a intelligent segmentation or intelligent classification is provided even in your messages. In fact, in my iPhone, my messages are automatically filtered as a promotional, transactional, and general messages. So such classification really helps me whether to review certain things. The transaction messages always I review to try to see that nothing is getting fraud. But promotional offers, I just look at it, delete it once again. So such classifications will help you to make the decisions faster. And similarly, when you're really looking into the goal for any particular recommendations if you want to apply, especially in the area of the books, what you normally see in the initially, you read one book, then it comes and says that people who read this particular book also, I recommend this book. These are all possible because looking into the different readers and their behaviors of the reading, the people who read all thriller books or comedy books or the uh, entertainment or the thriller related books, they'll get this likewise recommendations for the people to look at. So the behavior patterns is captured and accordingly the recommendations are offered. So you normally see when you go to the Amazon.com and you try to buy a product, it will say that the people who bought this product also bought the another set of products. These are all some of the insights given out by the machine learning for the people to understand. So similarly, some of the applications in the recommendation segment, you see that which movie should be recommended to what kind of a user. Whether user is listen to the songs or is going to respond with a feedback or like. So which news articles are relevant for a user in a particular context. So basically it tries to filter and give you the kind of a recommendation. These are the interested articles. In fact, I'm not sure how many of you have InShots as an application. InShots, you can also put down your preferences so that it automatically filters and provides only those things which is of your interest. And based on the context of the intelligence of that particular mobile user, means some of the ads which are coming and flowing in, it's primarily because it understands what is your past searches. It uses the uh, past searches of your content and try to get the specific related thing. Let us say, for instance, I go and search for a particular furniture. For the next few hours, wherever I go, I start getting the targeting ads related to that particular furniture. How it is able to capture? It is able to capture because of the context around the same. And similarly, which products are frequently bought together? That's what we talked about, right? The recommendations of one book can lead to another book because similar kind of a pattern was observed in the historical data. So historical references will help you to arrive at the predicted recommendations. Sometimes the pattern changes. Again, it tries to relearn and try to reinforce that particular learning and come back with better recommendations in the future. But you need to also be aware of the fact that it's not always that AI is always correct. Sometimes AI also could result into some failures. So it's important that you understand and appreciate some of these particular systems will be evolving to a higher level of maturity when it gets covered through the set of data, volume, velocity in mind. So way back in 2015, there was a Flickr who released an automatic image tagging, fall into a trap that anything which is in black in color can be considered as a name. That was a characteristic of a name, but that is not the only characteristic of a name. So even people with black color, it was started living. That's where the problem came when the Google get into the situation where some of the human beings were considered as a gorillas. So similarly, that kind of a discrimination was understood, and immediately they would withdraw that particular system from the marketplace. So if you do not train the data, or if you train the data with some bias element, or if you do not give any kind of a full length characteristics of this particular image, systems will fail to identify and try to classify or try to recommend. Similarly, Amazon had a very good interview program which has been popularly leveraged for doing the first level interview of the candidates in the USA. And initially it was working very well, and it was providing a very good filtered recommendations and going on well. So one fine day, what happened was that bot was trying to interview some of the candidates in the college, and unfortunately, it has rejected every candidate in that particular college. When it was investigated, it all came to know that the bot was rejecting because the college has all female candidates, and the bot was trained with a male bias. And it was trained in such a way that it is only he, or because of that, when all the female candidates came, for all that, it has just rejected all the candidates. So such kind of a bias is pretty much possible when you're trying to deal with a machine learning algorithm. So it's important that you need to be having a very unbiased trained data set. And in order to say so, you need to have an explainability for your entire set of conclusions. So any machine learning algorithm which you try to adopt and develop and realize, you need to have the ability to explain that. That explainability can ensure that you are developing the algorithm which is unbiased. And in order to do that, you need to ensure that the feature engineering is very, very important. And feature engineering ensures that you are identifying and capturing the features of that and trying to recommend appropriately. So when I talk about that, it is important that you understand the machine learning process. Now, irrespective of the areas where you're trying to work, whether it is a 5G, 6G communications, or it could be the retail industry, healthcare industry, anywhere. You see, machine learning process has got a specific sense. Like you need to establish the features and engineer the particular features because that's the characteristics under which a machine will be able to understand. Just like a human has got a eyes, nose, mouth, ears, hair, face, the structure is understood. Right? Similarly, a particular product or an image will also have features which you need to engineer. Once you identify and engineer that, you should start training with a different data sets. Your learning data set could be different, with the test data set could be different, training data set could also be different. Once you do that, you try to evaluate the metrics, mostly in terms of accuracy, in terms of your precision. Your algorithm can be very, very low at the initial stages. It could be 20 or 30% or 40%. But the more you try to train the machine or algorithm, it will be able to improve the accuracy to a higher level. The three important metrics we are going to touch upon, it's about precision, accuracy, and recall rate. These are the three metrics which you need to be aware of. It's a cyclic process. You try to arrive at the metrics where you are more satisfied than anyone else. Till that, either you discard the model or you improve the model. When you discard the model, you try to come up with a new model. When you want to improve a model and optimize the model, you try to see that the approximation of the precision rate is improved and recall rate is reduced. While you are satisfied, then you go into deployment mode and serve it and try to ensure that uh, system is getting into a purposeful use. So when you are trying to look at feature engineering, some of the important elements what you need to be aware is when you try to derive the new features, you need to derive using either through the aggregation. Aggregation is all about count or sum or even max, average, standard deviations what you're trying to look at, or It could be the temporal based of new temporal features what you try to identify based on the time windows. Basically, you can define the time, elapsed time into separate zones and try to say first zone, whether it's a peak time or off peak time. Accordingly, you try to determine. Or you look into the trends. You try to see the trends or trying to see the behaviors accordingly. You try to look at. And you can also look from the continuous or categorical feature sets where you try to enumerate certain features and try to label them. If it's a supervised way of algorithms you're trying to bring in. And categorical to the binary, you're trying to enumerate the binary features like for 0 or 1, what you try to really look at. And similarly, domain specific feature sets, what you try to look. So domain specific, when you say about go to the finance domain or supply chain domain or inventory domain, that particular domain areas will have a specific features which you need to be aware. So typically learning, when you're trying to look into the, once you have identified these particular features, the learning process comes in. The machine learning algorithms broadly classified into the unsupervised learning or the supervised learning methods, which you need to be aware. When you're trying to see the unsupervised learning methods, basically it's all about clustering techniques or the dimensional reduction techniques where you are trying to utilize some K-means algorithms, principal component analyzers, or any kind of SVD algorithms like vector definitions and other things, plays an important role when there is a continuous set of data which is coming in. And if it's a categorical data where you are trying to specifically define certain categories and you are trying to say, I want to use, then you use the macro model or the pre-close model or many more algorithms which are playing around. In the supervised algorithm is where you get the data set, but they are a labeled data sets. In unsupervised data set, it is not labeled. And one of the common example people have leveraged unsupervised algorithm is in the game theory or gaming sense. Basically, you're trying to teach the machine. You're not trying to teach the machine. You are only giving the rules to the machine, and it need to operate under the rules. And when it tries to play with an expert, it keeps on failing, but tries to learn from the mistakes and try to improve the strategic steps in making the moves. Especially AlphaGo, which was a very popular game in China. Initially, the entire algorithm which was written was in a very low set of code which was involved, and it has only the rule guide available, and it was only looking into that and intelligently leveraged, and it was keep on losing the games initially, but as and when that algorithm got improved based on the historical gaming patterns, it was able to beat the number one player in AlphaGo. Likewise, similarly, in the supervised, the labeled data set which will come in, because it's an opportunity to really look into that particular area. It means it can apply for the recursion algorithms like linear or polynomial. Then whenever there's a decision trees to be made, you can really look at it. It also can be applied in the classifications when there is a categories which are available. So some of the algorithms which is listed down here, not necessarily that all algorithms play an important role in every place. Sometimes some algorithms give a better efficiency, some algorithms does not give a better efficiency. It depends on the data sets what you're trying to leverage and apply it for. So you need to test with various models, look for the best option and try to move forward. The intent behind for me to talk about the featured engineering learning is, irrespective of the problem what you're trying to solve, this basic process is followed every day. And the third important step in the entire machine learning process is evaluation. So how do you really evaluate the accuracy of your model? So people will start giving you some test data sets which is very fictitious in nature. So trained data set which is much real in nature. Because trained data set comes from the past learnings, where the test is like it could be the fictitious or it could be futuristic in nature, which you need to really leverage and predict the future. So most importantly, you use either the two-way partition techniques or the three-way partition techniques. In the two-way partition techniques, you try to see the behavior difference and the output difference between the training datasets and the test datasets. While in the three-way partition, you also look between the training and test dataset, there is a validation set. So this will really help you to not only model the performance, model the data sets or model the algorithm better way, but it also helps you to model the performance of your algorithms. Remember, uh, the most important element is not developing the machine learning models, but ability to scale the models when the volume of data is quite high. Because whenever you're trying to deal with the machine learning systems, you're not running with smaller data sets, you're running with larger data sets. And it is important that your ML model need to have an ability to learn large data sets, apply to that context, and try to give out recommendations at a faster pace. And this classifications, when you're trying to do as part of the evaluations, you normally get into a situation where it's a false positives, true positives, false negatives, true negatives, which generally emerge. And basically these are all possible because of there is a what is the difference between the predicted value with the actual value. And if it's a true positives or false negatives, that is fine. But when the experiment results into the false positives or the true negatives, then that is where the challenge comes in. And mostly we fell into this particular trap. And you need to understand that these particular areas can need to be minimized as much as possible to ensure that your model accuracy is improved. And these are all possible when you try to evaluate and try to understand what kind of a threshold under which I need to operate. So you can really detect the outliers, and you'll be able to understand where actually my values are falling. So you can see this kind of a graph which is trying to represent that what are the known and real values and how you are trying to evaluate, trying to understand. So this determines to tell you that how the closely when you try to plot the graph, how many records are really above the cutoff number and how many records are below the cutoff number. So wherever you see there is a false negative, false positives are there, uh, they are representing the truth in this particular data, and you have an opportunity to determine whether to have the data or you consider the data as an outlier. So your observations are typically between this range of 0 and 1, and anything below that, they are outside this threshold range what you need to really look at. I mentioned about the three important metrics which plays an important role in the machine learning process. The three important metrics are accuracy, precision, and recall. Any kind of learning, you need to be start measuring these three metrics. These three metrics plays an important role as part of the overall learning. And when you look into the accuracy, the way you try to compute that is the true positives and true negatives with respect to the sum of that divided by total population. And if the accuracy of your algorithm is high, you consider that the model is performing and behaving according to your merit of the need. And again, precision also plays an important role. So when there is a high level of precision is there, means whatever you're trying to predict is really going to get it happen. It's all possible when you really look at the percentage based on the true positive divided by true positive plus false positive. And remember, you need to have a high accuracy, high precision, low recall rate. And when it is low recall rate, you see true positive plus false negative is taken into context. So you really try to define the trade-off when you're whether you want a low recall rate or high precision. So precision versus recall will be the really plays a very important role when you're really looking into the decision of choosing the model or finalizing the model. Okay, so you see that there is a resemblance of the three different use cases. When there is a perfect recall rate and a precision, means recall rate indicates that your sample is completely divested and you need to get back there to retrain your model. Low recall rate indicates that there is a very low sample which is going to recall and precision is quite high. And if you want to establish the balance, you look into the possibility of arguably the balance of good recall and precision. That's where you try to decide whether to discard the model or improve the model. So these three important metrics plays an important role when you are really looking at any kind of a change. So that is the first segment of my talk, which I'm trying to establish the applications of machine learning. touch upon the classification, clustering recommendations, and which plays an important role. Where to apply, when to apply, and where to apply, and what are the metrics you need to really consider, like accuracy, precision, recall, while you are trying to develop the machine learning models. Now, having said that, let us understand, move into the second segment of the talk about the 5G. So, what is happening today? If you'd really see today, the new opportunities are really emerging because not only because of the behavioral changes in the society, but also some of the change in technologies which is driving the change. So there is a huge amount of customer expectations changed over the period of time. Looking into the gadgets, looking into the software, looking into the behaviors. People have really shifted their entire thought process and trying to say that I want to leverage artificial intelligence and augmented reality. The gaming world has really changed the perception, and it has brought in the concept of the augmented reality, where it tries to bridge the gap between the physical and digital worlds, what we call the digital worlds. And these are all possible because of the kind of a traffic growth we have seen over the period of time in the last decade, which is almost 10 times. And the way the entire applications which has been developed and released were able to see the seamless or ubiquitous computing between switching between multiple gadgets and devices, yet see the same experience. You can see that entire traffic growth over the period of last 8, 6, 7 years. It aggregated more than 23%. This is the data from 2013 to 2018, but if you really look at now, it has even more than 45%. And because of the advent of the cloud computing, people have started leveraging SaaSified models, everything as a service models. People are trying to leverage and optimize their costs and improve their return on investments. And these new business models which have really emerged were able to provide the services to the customer at a low, low, low cost. That not only enabled that enabled the scenarios where you can drive the internet of everything, where it's trying to bridge the gaps between the people, process, data, and things. In fact, with the ability of the IPv6, what we call, literally you can give IP address to anything on this world. With IPv4, there is a limitation, but with the IPv6, anything which is constructed, you can create an IP address, create a sensor, and make it a communicable device with respect to the Internet of Things. Sensor can be associated and can start communicating. So such kind of trends which are being observed, and you need to be aware of the fact that these are all possible because of the advancements in the communication, advancements in the speed under which it is trying to communicate. So typically what you have seen as a difference in the 4G versus 5G, you could see that there is a significant shift from the latency from 10 milliseconds to less than a millisecond. The data which was existing today has significantly improved, and from 7.2 exabytes per month to the 50 exabytes per month, which is as of this particular year. And you can see the peak data rates really increase from 1 gigabytes per second to the 20 gigabytes per second. In fact, in 6G, we expect this to grow to terabyte. Similarly, the spectrum under which we are trying to operate also changed from 3 gigahertz to 30 gigahertz. And the connection density, and that's where people say, right, they fear about the high hotspots available, and the kind of a radiations will be very high because of the connection density, which has been 100,000 connections per square kilometer, now increased to the 1 million connections per square kilometer. This will significantly improve the increase the radiation and might be a danger to the world. And you need to be remembered to the world that there are 17 sustainable development goals which has been released by the UN to ensure that people do not compromise on the sustainable development goals, which is going to harm the humanity. The entire focus of the 5G revolution was driven towards the 6G related humanity drive. Means when the spectrums are increased, when connection density is increased, when the latency is reduced, when peak volume rates are increased, you cannot compromise on the radiation which could be harmful to the humanity. So there are several measures which are taken into account, which ensures that the safety and humanity is safeguarded and respected. So the entire ecosystem, which is playing a role as part of the 5G, is really transmitting and enabling the business to anything kind of ecosystem. It really opening up a plethora of opportunities for every industry vertical with the advent of the speed of what 5G offers and latest 6G offers. Looking into the specific use cases which is really enabling driving the business. Now, five important elements what we have learned in the past slide, also I'm trying to recall here. Ultra reliability. What does that mean? Wherever and whenever, whatever you try to access, it will be the same. So you have a reliable data set which is coming in. Ultra capacity and coverage. This is important second area of investment. Because of the needs emerging high, the volumes are significantly high. Earlier, let us say for instance, before the pandemic situations, how many times you have ordered using Amazon or Myntra or any other online channel? Post pandemic, how many times you might have ordered? I hope and I'm sure that this might have increased. If you really plot the data, at least it has increased 3 times or 4 times or more than that. So if such kind of a volumes are increasing, what is that it is needed? It requires a high speed network, ultra high speed network, which can change. And when it is trying to drive the change and handle the demand, it needs to respond faster. In case any transaction you do, if it is not faster and does not have a low latency, you will be worried. Your anxiety levels are increased. So it is important that you need to offer the ultra low latency, that is 1 millisecond end to end, so that it is faster and quicker. And massive device connectivity is important because today any home you take now, with the smartphones, with the Xboxes or kind of a Tata Sky boxes or Binge, whatever you feel called, uh, there are not less than 10 to 15 devices in the home which has got an opportunity to connect with internet. So at a one single home, if such many devices are available, think about the entire globe. How many devices could play an important role? Let's look into some of the applications which is really triggering that change. The fun important area where you see applications playing an important role is the perfect video. So broad access in the dense areas are really triggering. Now let us say for instance, today how many videos are getting streamed? How many movies in the OTT channels getting streamed worldwide? Imagine if that need to be streamed and you should not see that word called buffering. See, understand about the density or understand about the bandwidth availability for your device to stream the data. Probably before 4G, if the same movie is getting played, you could see buffering before it gets played for 15-20 seconds. Again, it goes and buffers. But with the availability of 4G and 5G spectrum, you will be able to see that seamless communications. And high-end quality videos can also be played at the similar speed when the 6G comes. And similarly, you see that there is a broadband access is getting everywhere available, urban, rural areas, remote areas, and which demands at least 1 gigabits per second per device is required. With the availability of such kind of reliability and ultra high speed and low latency, high speed trains can drive very fast. It requires so much sensor data to communicate, to look into the safety measures and look into the speed measures, look into the kind of a actions it need to take at a very short interval of time. And because of so many things which are participating in the entire zone, and sensor networks playing an important role, it's important that these characteristics are supporting such many devices. Now, imagine if you really want that autonomous vehicles to be real in the entire country, the speed at which these autonomous vehicles need to communicate is quite high. And that is only possible with the help of 5G and 6G network availability. Otherwise, things will be only very in a trial mode, but not in real mode. And with the availability of the tactile internet, to make the things much reachable to every zone, uh, to provide the real-time communications, also demands such kind of a ultra reliability and ultra capacity and ultra low latency areas. And you look into the natural disasters, means if something happens in some remote areas because of some natural disasters like floods or earthquakes, so it's important there's a quick communications to be established so that there can be safeguarding human beings or humanity to proactively. And you see that this communication also plays a very important role in the e-health services and also in the broadband services, which is important as part of the overall journey when you really look at. Today in the pandemic world, there is a touchless environment which is getting created. Many people are taking the telehealth services. And when you're trying to take the telehealth services in a touchless mode, it's important that you cannot have a uh, breaking network at any point of time. You need to have a very seamless network to offer such kind of a capabilities. Similarly, we have heard about the OTT services or the medias, which is trying to demand that how fast the services can be broadcasted everywhere. In fact, there is also a greater investment which are happening to improve the computing speeds. We have heard about CPUs, GPUs, tensor processing units, now quantum processing units are also coming in. The speeds can be also improved when the quantum processing units can come to the reality. So the ability to process, respond is also very, very high when such kind of a processes emerge and come in. And let me briefly touch, I'm not getting into the details, but you need to understand as a faculty how this architecture revolution changed over the period of time. So you see that 4G architecture was primarily trying to have the mobile devices trying to communicate to the nodes, and then there is a backhaul aggregation to the IP edge devices, which is trying to process, and the centralized data centers were able to communicate and trying to establish the connectivity. But in order to achieve the high speed, ultra reliability, ultra low latency, there was a thought given that can we virtualize this? Can we distribute the workload? Can we make the edge computing more powerful and make more real? More real. Decompose this entire network in such a way that it is faster and there is a front haul and back haul systems available which can completely leverage the radio access networks to fabricate the data sets and also route the request faster. So the intent is to fastly route the segment requests and orchestrate in such a way that you will be able to communicate quickly across the devices. There is no need for you to communicate to the central data center to come back, but that can happen as a backend control plane communication. But within the network, you have the front haul systems which can completely leverage your radio access network, virtual radio access network, and drive that communication. And this is what we call as a overall virtualizations, which is trying to make the things faster. And how this particular data is segmented, network sliced, within that specific spectrum of the data, the slice of the network, you try to communicate and fastly drive the change. So what is really enabling this particular technology when you really look at? So not getting into the complete length of the things, I believe some of the talks will be really getting into that three elements which are spoken in the morning: uh, massive mobile broadband and machine human like communications, and likewise. You can see here the four elements which has been touched upon. The first one is about the controlled user plane separations. That separation is really helping you to virtualize the operations and operate the things. You can see also cloud scale networking with cloud radio access network and and software defined wide area network, what you call, where this front haul and back haul systems are introduced. Earlier it was not there. Now it's front haul systems are introduced for the quick communication response, so that it can really connect to the virtual core. For the scalability, you can see that achieved through this MEC. It is trying to ensure that the faster and compressed videos can be communicated so that there is a faster way of reaching. And based on the data sets what you try to provide or the category of the things which is trying to provide, you are having the network slicing so that it can completely leverage that communication. If it is a binary mode of communication, what kind of a network slice you need to use? If it's a core network related or manufacturer related data, what kind of communication you need to use? If it's a mobile broadband communications, what kind of a core communication channels you need to use? You use this particular slices to determine and try to change. So these are some of the important elements. Probably you will be having a deep dive faculty development program sessions, which are going to touch upon all these 4 areas as you try to progress. And just trying to give you a high level view of it. Now, having heard about 5G trends which are going to drive the change and understanding the uh, change between the 4G to the 5G and also understanding the overall architecture and enabling technology, let's look into the applications of where it gets really applied. From the mobile edge computing, edge devices are becoming even more popular. Edge data centers or edge locations are becoming even more popular today with the advent of the 5G technologies in mind. Now, radio access network workloads which are getting deployed at edge are becoming even more powerful to provide the immediate benefits. That's where the fronthaul services comes in. And mobile content delivery networks, CDN, what it means is content delivery networks, and where you need not go to the say for instance you have downloaded a video and you are streaming it. Second person wanted to download the same video and you are adjacent to it. Your device is an edge device for him. So he is not going to download it from the same location, but since you are near, you are a edge device, you are going to download it from that particular device. Your bandwidth consumption will be less, your speed will be high. The ability to communicate that this is a device available and it is an edge device available for you to download, everything is taken care by the virtual printer. So such powerful edge caching techniques are leveraged to ensure that you get that capability built for you. And that intelligence is possible when you're trying to have the automated routing techniques defined. And that's where again the machine learning plays an important role. How these routing techniques to be leveraged need to have the intelligence context. Yes, this edge device is available with that kind of a data set. You can completely download the data from there. Similarly, connected and autonomous vehicles, when you see, also require a lot of low latency. So any vehicle which is going on the road, you cannot expect the request to be routed to the data center to get the information back and try to respond. It needs to have a powerful sensor networks embedded, and the devices should be very much localized, should be able to compute, make the respond to the situation. Well, you can always distribute the computing, but you can always try to send the information back to the cloud at a later point of time. But the decisions need to be less than a millisecond indicates that you need to be having a local edge devices to compute that. And similarly, in any of the Internet of Things, industrial IoT, where fog node performs latency, the fog node, it's the nearest node, what we call nearest node for you to compute the things and try to uh, uh, provide the feedback to the data center. So such kind of an activators which are placed or sensors which are placed plays an important role in fastly computing and delivering the use cases. And these are all possible when you try to virtualize, when you try to leverage the network speed to offer the decisions. And the augmented reality stories. Now, AR is becoming even more popular in the smart in Vedantu or Byju's, this kind of a normal hats what we see in the Indian community, right? And they say about the smart education, making you feel part of it. It's all about augmented reality coming into the picture. So you are really trying to augment the physical and digital world and try to bridge the gap and making you part of the flow to educate yourself. So augmented reality is becoming very, very popular use case as part of the 5G story. And smart education becoming a very much real use case where you will be seeing the AR playing an important role. Not only smart education, smart retail, smart agriculture, all the things which are associated with the smart can bring in the augmented reality as an example to behave. Similarly, in the gaming world, you see that the amount of motion under which you try to operate, it not only leveraging the local processing speed, but if you're trying to compete with the other person at the other location, and both are playing the game from the two different locations, remote connections need to be established and you need to drive the change. So today you see social participation to make it very, very popularized. And they really ride on the wave of the 5G networks to achieve that objective. And the workload hosting through the public cloud provider also leverages the different edge locations or edge devices to perform these functions. Today, As Sachin Adeli said, edge computing will be ruling the world all over. So edge becoming a very important area. Your smartphone could be an edge device, and it is important that you subscribe to the thought and try to model your entire working style accordingly. So any use cases which demands a faster processing speed, you need to understand as part of your architecture and design how well you'll be able to leverage the edge devices to perform the things faster for you and uh, make the ability for the system to function properly. Say that's what I'm trying to say, right? Whenever I want to download the content from the Google, I don't go to the application. I But now I'm not even going to the content delivery network because now all edge devices which are subscribing to that particular content can become a content delivery systems for me. So instead of earlier, anytime I make a request, I used to get it from the data center. With the 4G, I was able to get it from the content delivery network. With the 5G, I'm able to get it from the edge devices. So such way, I'm able to manage the speed much faster. And this capability is really building out uh, a different level of the license spectrum across the world. As I say, it's not only that, you need to be aware of the fact that there is a thought given to the fixed wireless access. Some of these problem statements I'm trying to touch upon, uh, you need to be aware. And they are trying to do the last mile connectivity problem to be solved, right? The service providing, they are trying to spend a lot money on connectivity. Basically, that the last person in the world, means in the entire chain, is able to reach through this particular network. So there is a new fiber copper connections are established. There is a competition which is trying to lease and provide. So they are trying to ensure that all the possible channels are leveraged to connect the unconnected world. So while doing so, you need to understand that they also try to see that how they optimize the wireless network. So there is a huge focus given on the infrastructure level to analyze the data sets. In fact, machine learning algorithms plays an important role in the infrastructure level also, where you need to understand what kind of a spectrum is underutilized. Are there any resources which is not utilized, so I'll be able to leverage it for the new requirements which are coming in. And they also need to ensure that they need to solve the problem associated to the user experience. Anything disturbing the user experience gets unused. So it's important that you understand the growing demands, understand the growing challenges, and try to target those things and achieve it. So there is a focus which is going on across the world that when you're trying to deploy the 5G fixed wireless, there is an enormous number of market opportunities available. The number of segments that you try to reach, the number of uh, industries we are going to adopt and utilize will be significantly high, which could yield higher revenue. While that is happening, there is a good amount of investments which you need to make that happen. You need to buy equipment, you need to have the high power consumptions, you need to have the real estate to put on your network, you need to have the entire structure to maintain and install and repair services, and you also need to maintain the entire network of telecom operations which are happening. So these are all tied together. There is a quite number of investments, and there is also huge immense availability as part of the revenue. When you try to balance this kind of economics, you'll be able to yield a higher return of investments. And that's where again, machine learning plays an important role to optimize your cost by by making the utilization of the underutilized spectrum, optimize your cost in ensuring that you improve your entire device power efficiency, optimize your real estate space. So when such kind of a focus is given to reduce your total cost of ownership and improve your return on investment as well. So when you're really looking at, you also see there is a huge amount of extension is provided to the enterprise network. When you really look how you drive this network as a service. So you see there are a couple of things which we are going to touch upon is about open roaming and a user domain center, unified domain center, what we call. But beyond that, you see that these networks are extended to the edge services, which is significantly connected with a secured internet gateway, mobile SD-WAN, software-defined ID network, core deployments also. So to see that new core deployments, which is trying to yield through the 4G networks or the 5G networks, which is getting introduced. But mobile SD-WAN and SIG edge services will be even more real when you're trying to bring in 6G into the context. Let's understand what is open roaming is all about. So basically, it is trying to provide a federated access. And when you are trying to switch across the different providers, and say for instance, you have a Airtel network, and Airtel network you are trying to communicate with one location with another, but suddenly you move into a network where Airtel network is weak, Geo network is very strong. Your ability to switch to that federated network to the Geo and offer the seamless connection is important. So open roaming identity federation tries to offer that capability to switch your networks and immediately provide the similar kind of a seamless experience to the user. User really doesn't matter as long as you get a service, whether it is provided through Geo or Airtel doesn't really matter. That federated connections, federated switch is very, very important for seamless roaming of these enterprises when they are really looking at. They wanted to productionize this, and that's where you have a proper handshake between the defined policies, standards, identity, and locations, so that you don't try to invest over cost, but you try to optimize the cost by sharing the network. The Unified Domain Center is trying to completely optimize your software layer. It's trying to ensure that there is a single pane of glass. I mean, single pane of glass is nothing but it's like a dashboard available from the enterprise perspective, where you have the full statistical view of what is happening in the network, whether in terms of Wi-Fi access, whether in terms of the hotspots, whether in terms of connections, whether in terms of any fault situations, fault isolations. You'll be able to filter, apply all those things as part of the Unified Domain Center. So these are all possible when you're really leverage the data in the field to relate back into the domain data center for making the decisions faster. These are some of the second capsule related information which I thought of telling, where you have a clear view about what 5G applications which are emerging in the market and driving the change. Let me also touch upon the 6G evolution towards machine learning and AI. We have seen and witnessed about the 3G and 4G adoption across the globe. But there is an emerging need of developing the standards. That's where I told you in the morning, right, about 3GPP, IETF, and ITU, who are really playing an important role in developing the standards, which every network player or everyone in the supply chain of the 5G communications or 6G communications playing an important role across the globe. There are two important levels where machine learning can be played. One is a user and application level, where you try to determine the need of the different applications to perform at a lower latency or greater privacy and high scalability. The second area where you try to determine is at the infrastructure level, where you try to optimize the entire end-to-end communication channel. You look into the power efficiency and power allocation spectrums, looking into the how you optimize the data validations and switching across the networks, and also how it will be able to learn from the fault isolations or fault situations so that it can perform better. So there is a significant investments which are going today in studying and trying to tackle into the research problems associated with the 6G standards, which can be even more powerful and adopted as we try to move forward. So as the time progresses, you see there is a huge amount of investments are placed here, and there are a lot many big bets which are going to we are relying upon, which is going to make this entire world to be smart and connected. The goal is to be a smart and connected world. Now, what are switching to the 6G area? Where I need to spend? What are the areas where the machine learning can be really applied? So one of the key critical area where I see there is a huge amount of opportunity for everyone to look at is the network performance management. Even though there is a high bandwidth is available through the 6G network, but you still need to optimize your network performance. You cannot use all the bandwidth routings available, right? You need to have the optimized routing paths. So looking from the left, from the enhanced performance section, when you try to see, you need to see that how AI can really drive the managed mobility. So managed mobility will be really demanding the changes from one device to another device, because today whatever the device I use, when I go home, I may switch my device. The behaviors will be different, the form factors will be different, but the transactions or the interactions cannot be compromised on the experience. So that requires switching the ensuring the transferring the context, and also ensuring that the experience is not compromised, and that requires good amount of speed, cache, and latency to be managed, so that you have an opportunity to understand the overall behavior and manage the traffic accordingly. And coming to the better deployment, it's important that you cannot have a very head of questions. So today, when you are trying to handle such billions of devices which are participating in the world, so you need to have very software-defined networking, which will ensure that the spectrum allocations, power efficiencies can managed. Your topological, all the topologies which are associated to the network topology, what we call, need to be optimally connected and defined, so that your number of hops which are happening to reach the content is reduced. We have seen in the previous sections front haul and back haul. Front haul was not existing, but with the advent of 5G, we have introduced a front haul to determine if this content exists somewhere else, to determine the edge locations or edge devices from where this content can be consumed. That network topology plays an important role to optimize and improve the network performance. And while the performance and scalability is achieved, you cannot compromise on the security. So you need to understand the threats which are going to happen and determine how this particular security assurance can be offered over the period of time. So analyzing the data, analyzing the change in behavior of the data, and also arriving at a threat, making the threat detection really make you to improve the data transmission and communication in a very secure manner. So that assurance is important for you to live upon. If people say that your privacy information is getting compromised, you will not be comfortable sharing your data across the network. So giving such kind of a security assurance is also very critical as part of the 5G and 6G networks. The other research area of the challenge where you can really play an important role is improving the network efficiency. Looking into the different infrastructure level utilization and tap into the unutilized spectrum and making it the high peaks are coming really make the high make the entire intelligent routing to be much more. Today we see that not knowing that unutilized areas, you will be end up spinning out new machines. So you see today the elastic behaviors in the cloud are popularly leveraging that behavior to understand the unused utilization of the processing capability and try to utilize them. So you will be able to improve your congestion management. You will be able to improve your entire admissions of the new devices into the spectrum faster and quicker, and roll out the services also faster. So this some of the slides which I'm showing to you now is courtesy to the University Follow, who are the people first group across the world who have started the first 6G research program. The goal of this particular research program was to establish the 1 terabyte per second capacity, ensuring that it's providing that wireless connectivity at that level. It's not an easy problem to solve. Huge between the last 2018 onwards to 2026, around 251 million euros, who are really driving these flagship programs across. And the intent is try to build that kind of a communication spectrum of 10 terahertz with circuits and antennas, so that you can have a unlimited connectivity and enable the edge devices and edge locations to drive the distributed computing, which can empower to construct and conceive the augmented reality or virtual reality applications. So it's important that the third goal is like they want to achieve the distributed computing. The fourth goal is they wanted to create disruptive value networks, which is trying to drive and enable that services and applications. So there will be a lot We've seen so many disruptions happening so much, like blockchain, quantum, and AI and deep learning are trying to drive the change. Uh, like you could see about Amazon, Ola, Uber, Netflix, who have really disrupted the industries, Airbnb, with the power of all this machine learning and applications of machine learning of in that space. So, if you're really looking forward, what is my future? How the future smart society would really look at, and it's important that you start realizing the key differentiators between the 6G and IoT and AI. We keep trying to interchangeably use it. So, so when you are trying to talk about the artificial intelligence, it's more important that you are aware of the context and you are trying to develop the context in such a way that it is optimized, automated, and unmanned. So there's a analytical view which is available to make the decisions better and faster, looking into the context. And then the sensors which are participating, the devices which are participating, and they need to be empowered to be self-operating. They should not be depending on someone else to do it. So with the empowerment of the device processing capability, ability to communicate across the interoperable sense across the world, you're making systems participate. It's a systems of participation which is going to make a big difference. Uh, and when you have the behavior of analytics, when you have the systems of participation coming together, you are trying to really reach to that particular scale with the power of radio access networks and to offer low latency at real time, ultra fast, adapting to the new challenges which are emerging with the 6G. And you see that these are the key enablers which are going to make the big difference as part of the overall journey is how will be able to leverage the key elements of the communication materials, electronic circuits, sensor devices, and from the reliability standpoint, you see that you cannot compromise on the privacy across. In order for you to have the interoperability achieved, following that standards which defined by the ITU, IETF, and 3GPP makes an important role for massive mobile broadband access. And the flexible and modern architectures are going to drive the change under which this entire wireless intelligence edge is going to build our future society. So these are some of the key pillars which are going to make the tremendous change as part of a forward-looking requirements which are going to emerge in the smart societies as we move forward. Some of the technologies and the applications which are going to disrupt as we try to move forward. Anywhere you try to see there is a need of the real-time data, edge processing capabilities, process the artificial intelligence, will drive the change, will adopt and leverage the 6G technologies. Especially the factories of the future, the automated factories, are going to make a huge change. You can see some just show those Kiva robots which are trying to go across the factory and automate some of the important areas. Basically, in Amazon warehouses, you see that Kiva robots plays an important role to pick up some of the some of the parts from the different aisles in the different locations. In case if you don't know, Amazon, some of the large warehouses are more like a 400 football grounds. And in that 400 football grounds, when there is a millions of parts are available, it's difficult for anyone to go and get the part to pack and distribute. That's where the robots plays an important role. And smart health, if you are really looking at, it really requires wireless sensor because when you're trying to communicate with the doctor for any kind of a diagnosis, the sensing plays an important role. The computer vision plays an important role, and the ability to analyze the mood and gauge the mood also plays an important role. And your ability to provide that statistical information to give the right prescription also plays an important role. So smart health is becoming a very important area which is going to get disrupted with the advent of 6G technologies. The personal experiences when you are trying to look from the augmented reality in the retail or agriculture or smart education, uh, the managing the preferences, computer vision and sensing systems also could get disrupted. The automated vehicles, that autonomous vehicles, fully autonomous vehicles, leveraging the swarm AI, basically uh, each each vehicle which is going on the road could be a sensor by itself, and could be an edge by itself, communicate with each other, so that there's a machine-to-machine communication is enabled through this radio access network to empower them to make the decisions faster and avoid collisions and uh, manage the entire journey very, very smooth and seamlessly. So achieving the terahertz radio access network, enabling through the wireless AI, ensuring that the secure systems are built, providing an augmented user experience, ensuring there is a smart sensor communication happens, empowering the IoT systems to communicate utilizing the swarm AIs, empowering the local processing power are the key enablers to drive the global use cases and drive the change in the entire society. So there is a plethora or enormous uh, use cases or applications available where machine learning can be applied and drive the change. So one key vision I wanted to touch upon is our society is completely data driven, enabled by the near instant and unlimited wireless connectivity. I believe by 2020, 2030, I would say, whatever the things which are not met with 5G, 6G will make the change. And you can see that smart societies will emerge and riding upon the unlimited wireless connectivity as we progress. Finally, I wanted to touch upon a couple of slides. You see that societal impact is going to make a bigger change as part of the AI network. We have seen the culture of typing to the clicking to the touching. And today, our devices recognizes our face, APIs recognizes talking, gesturing, looking. These are all nothing but mixed reality. And in the future, it's all about the brainwave thinking, which is going to drive the change and move from the machine to the human, to the machine to the machine. And you can see that autonomous agents are going to be very popularized to drive that change to build that entity to entity, brain to brain kind of a communication. And these are all possible when you start thinking differently and creating more impact in the entire journey. So I would say that with this slide, I would like to close my talk, and I'll be happy to receive any kind of a questions if you have any. But I would request you start thinking differently, and there is a enormous applications can be leveraged at an infrastructure level, user and application level, and which can drive the change. And that's it from my end. Thank you. And I have one important of talking to you and sharing that particular paper with you. There is a 60flagship.com where they have published some good, and I'm going to touch upon that. 1 minute. Okay. Yeah. So this is a key drivers and research challenges for 6G ubiquitous wireless intelligence. This is the first white paper released in the 6G area. Uh, this is coming from the University of Oulu. In September 2019, they have given that particular list. I would request you to review this paper. I will share the link to you. You can go 60flagship.com, 60 white paper, and download this white paper. It's very important for you to review this so that it will give you a very good head start on the understanding of the different 6G use cases, new device forms, how the different challenges are getting emerged, research areas getting emerged, 60 spectrum areas, radio hardware progress, physical layer, 6G networking, and different service enablers. So this section has got very extensive understanding, and it also throws you out some of the research questions that might be interesting for the faculty development as part of the faculty development program. This you can see some of the research questions are available here. When you try to ponder upon that, you will be start seeing some of the good quality white papers can be emerged as part of this research questions when you are trying to look at it. So 6gflagship.com/6g white paper, you can type in the Google, you'll be able to get there. Okay, thank you. And over to you now. Thank you. That's where I want to start.
Thank you, sir. There is one question from the participant. Difference between fog and edge computing, sir.
Yeah,
Sir,
what's your
am I
question?
audible? Yeah, they're
Yeah,
asking
you're
for the
audible.
difference between fog and edge computing, sir.
Fog and edge computing.
Yeah.
So when you're really looking at edge. It's all about you're empowering any kind of a device as an edge device, and your mobile phone can be an edge device which can play an important role. So when you today when you're trying to say that just to put it in a simpler terms, if I say that your smartphone is an edge device which has an ability to communicate about your data very locally. So whenever you're trying to make a specific transaction or a specific instruction to be sent, you see that it can be done at a nearest edge device available. So say for an instance in your home there are 5 devices available. Say for an instance in your home 5 devices available and one of the person has downloaded a movie. And next time what you want to say is you want to see in your device. So what happens? You will put the same instruction that I want to watch this movie. So when you say that I want to watch this movie, you are not streaming the content from the same data center, but data center knows there is a specific edge device which is available near to your device, and it will stream the content from that particular device to you. You are not at all aware of that. It's completely seamless. You'll see that the entire movie gets streamed to you very, very fast because it's streamed from that other device. So when you're trying to talk about the fog computing, it's processed at the node which is near. So this node is not necessarily the edge device. It could be a physical data center. So there could be data centers which are spread across, and these nodes could be subscribed to your machine or some other machines which are participating, which is part of the gateway. So the difference is edge leverages the devices nearby, fog leverages the data centers nearby. So that's a difference under which you may want to qualify. So edge notifies and understands and senses the devices which is nearby and helps you to process it faster, quickly using the devices. Fog leverages using the specific data center, nearby data centers to process your information locally at that moment. So that's a major difference.
So next question. What are the features used for M2M communication in 5G for machine learning, sir?
These features could be at an application level or it could be at an infrastructure level, I would say. And I'm assuming the question which has been prompted there is more focusing on the feature engineering. And if you can really qualify that particular question, then it will really help because you can take one particular use case as a spectrum allocation. Spectrum allocation could be a feature. The unused spectrum allocation characteristics can be understood, utilization metrics can be understood, and accordingly make the decisions to route your request through the unutilized channels. So when you're really looking at the features of the end-to-end communication, you segregate that entire communication using the application level and the infrastructure level. And in the infrastructure level, you're more focusing on the routing determination, spectrum determination, hardware node determination, which will allow you to make the decisions faster.
That's all we have from the chat box, sir.
Great. And I hope you will be able to enjoy this entire faculty development program. Very, very powerfully designed, and it really benefit for you to get a full wave of understanding technically and also from the business standpoint. There was a careful thought given to the entire program to give you the full length of the content. I believe you will be walking away after this faculty development program with very rich content and rich knowledge, which can really empower you to extend your knowledge through the research programs and research orientation, which can really play a new league for yourself. All the best.
Thank you, sir. I now request Dr. Kalyan to present the concluding remarks for the session.
Good evening, all. Good evening, Bala sir. So, good evening, Bala sir. This is Dr. Kalyan. Sir, you covered various real-time applications of machine learning with respect to 5G and 6G technologies, sir. It's a wonderful session, sir. And how the transformation happens from machine to machine and machine to human is very, very nice, sir. And you went through the deep insights of 6G networking, edge computing, fog computing. The differentiation you did between edge computing and fog computing is very clear, sir. Especially for beginners, whoever starting PhD program in the starting phase of research with respect to 5G communications. For them, this is a very, very useful session, sir. Why? Because while making SOP, while making problem statement, this kind of clarity is important, sir. Whenever they are starting research, so your session is extra excellent, sir. We impressed with your session, sir. Sir.
Thank you, Kalyan.
Thank you, sir. Thank you, sir.
Thank you, Bala sir.
Thank you.